can be generated maybe when any disease is maybe when there is a diagnosis of any disease, or when you are doing any testing, and maybe during research, waste can come up and can be generated during those period. And there's need for you to also understand that different laboratories, based on their areas, based on their capacity, depend on the type of waste they are going to generate. So medical laboratory are significant generators of infectious waste, including microbiological materials, contaminated sharps, and also pathological material. So there's need for you to understand how to manage them effectively. Now, okay. Now, talking about waste estimation now. If we look at the estimation of waste, we discover that based on the study by WHO, they discovered that 85% of hospital waste, they are non-hazardous. 85% of hospital waste are non-hazardous. Then 10%, they are infectious, and 5%, they are non-infectious. And that's why you see in your laboratory, you see that if you don't really have too much work to do in the main laboratory, you discover that the waste you will generate mostly, it will be not hazardous. So that is that. Then talking about who is at risk. All personnel, both the technical staff and the workers in the laboratory, even the cleaner, they are also prone to risk from waste that are being generated. So then now boils down to the public. We have seen situations where a laboratory personnel or a nurse or a doctor or whoever in the lab work in the lab, because of mismanagement of waste, get infected, and also go to his home and also infect his family or a family member. So it's very necessary for us to understand this. Now, type of medical waste. We have chemical waste, we have infectious waste, which also called hazard waste, and we have pathological waste. For those that at least work in maybe in pathology lab, we have what we call pathological waste that maybe it's the management of large tissue, or whether any tissue fragments waste. So very, very important. Now, when we are talking about a sample of chemical waste in clinical laboratory, it might include maybe fixatives, it can be clinical test tablets, that is maybe for those in pharmaceutical, and it can be maybe paraffin wax or xylene, which is ignitable and listed as D001 and F003. So they are also treated as hazardous waste. That's treated as hazardous waste. So very, very important. Other waste, there are other waste that also can come up. Maybe a chemical bottle that got broken, then the chemical is not useful again, or you use any chemical that lose its potency and you need to discard them. All those things are waste. So they have the way we can also manage them. Then when we talk about infectious waste, most of us we should understand what we call red bag waste. That is, if you see any red bag, you know that thing means that it is dangerous. That means maybe something of infectious, whether it's infectious or highly infectious. So, but hazard infectious waste is commonly called red bag waste. Then it's appropriate for maybe blood waste, maybe laboratory waste, maybe regulated human fluid. Then primary treatment for this waste is by autoclaving. For those of us that we are medical laboratory scientists, we all should understand that sterilization is the major way in which we can treat our waste in the laboratory. and it should be done at a licensed facility. Then, depending on the type of location where you find yourself, if you are abroad, there is an advanced way of managing waste. But for those in Nigeria here, yeah, we have some licensed facility depending on the state where you are that also take care of waste. Like for example, now if I use Lagos for example, Lagos they have a Loma, and Loma they have different segments in their offices. So that deal with waste. They have the medical waste, they have the general waste, they have the general waste, and then and both of them deal with different type of waste. So those medical waste are the one that handle health facility waste, laboratory, and the rest. So oftentimes this waste is then compacted and sent there to a special landfill. Now, common red bag waste in laboratories include fluid, blood, or bulk body fluid. That is like human-derived albumin, live or attenuated vaccine that are infectious to human. So laboratory waste such as conscious biological agent and attenuated live items that are infectious to human. So talking about pathological and large tissue waste, we call those ones yellow bag waste. So pathological and light tissue waste are biohazard waste that require incineration rather than sterilization as a final treatment. So most time, this waste is eliminated by the use of yellow bag and will be managed by the same disposal company as your red bag waste. So common yellow bag waste in the laboratory include human tissues from pathology, carcasses from research and animal waste. Then you need to note that some laboratories do not generate pathological waste. However, whenever your lab or maybe your facility is dealing with human or animal tissues, you must ensure you are using yellow bags rather than red bags. I hope that one is noted by us. Now, talking about how you can manage your biomedical waste. How can you manage your biomedical waste? These are 7 items I listed there. Now, you need to survey your waste that is being generated. It's not that maybe you just generate where you just manage them anyhow. So you need to survey them. When you survey them, you know what type of waste I generated or what type of level as my facility generated. Then by the time you find out, make sure that you reduce the source at which waste is being generated as much as possible. It's somebody that is wasteful that will always be having waste. But if you can manage whatever you are doing very well, it will reduce the amount of waste that is being generated. Now, segregation of hospital waste is very important. So when you have surveyed them and you have reduced the source in which you generate the waste, then there is need for you to segregate your waste to general waste. General waste are maybe those things that you use maybe in your facility, maybe like all these food disposable, the cup disposable, food container, light leather or whatsoever. So you need to separate them. Then some laboratory, if you go to their lab, their facility, you see that where they are dropping their cotton wool that is being soaked with the blood, where they drop it is where they will also be dropping pure water, nylon, bottled water can, and the rest, which is very wrong. So collection of categorization of waste, then the storage of waste, then the transportation of waste and treatment of waste. They are very, very important. So if we are talking about the transportation of waste now, in the laboratory, there is need for you to place your waste bin in strategic places. Some people, they will be moving waste. If there is any waste they generated from the main lab, they want to bring it to the reception because that is where they have their bin. The only bin they are using, that's where they have it, which is very wrong. So the way it's being transported is very important, and the way it's being treated is very important so that you can be able to save the life of the public. Now, label for biomedical waste container and bag. Many of us, you will have seen this type of sign, biohazard symbol. You will have seen it. Sometimes they will not even write biohazard. They will just put this type of sign on maybe on the leather or on the container or something. What it means is a biohazard symbol. That is, this thing is not safe. Then you will see the other one that they put like C inside. That is what we call cytotoxic waste. It's a toxic hazard symbol. You can see the way it is. These are for most of the waste that's been generated from the pharmaceutical industry or companies. Now, look at the color coding. These are the color coding for the for different waste. And you can see yellow color, human and animal anatomical waste. Red color, tubings, catheters, IV sets, and the rest. Then blue or white container. But presently now, the container they used to use, they can put it as white. That's for sharps. So it can be blue, it can be any color. But if you see container for sharps, it used to be they used to do it in a way that it will guide the sharp object or the needle from infecting anyone. So it can be blue, it can be white. Needle, syringe, scalpels, blade, and etc. can be discarded inside. So then black, discarded medicine or cytotoxic drug, intination, ash, the chemical waste. They are the one that we use black color for. Now look at this the illustration that I put here. Now, not infested waste. Look at the way it looks. So cytotoxic drug and chemical waste, see the color, which is black, as I mentioned now. Then that is non-infected waste. That is this one for expired drug, maybe chemicals and waste and the rest, chemical waste and the rest. Then you will see the red container. You see the biohazard sign on the other three containers, the red, yellow, and the blue. You will see the biohazard sign, even the white, which is the sharp container. You will see the biohazard this on them. Why the one that is like not infected, they put it as a C, that is cytotoxic container. So inside this cytotoxic container too, the drug this thing can be there. Then general waste also, the color used to be black, where you throw your nylon and the rest. That's why the label is not infected. So you see all the other ones, infected waste. The solid waste, that is infected dressings, or maybe POP cars or the rest. So you see it inside that red container. Then you see anatomical waste inside yellow container. Those are the things I mentioned: body parts, tissues, fragment, and the rest inside the yellow container. Then maybe you have infected plastic, syringes, glove, and maybe plastic waste and the rest. So blue container is being used. Then we have sharps, which is white, is being used, where you throw all your sharp objects that you want to discard. So that is the way it is. So, but presently now, most laboratories, they only have three major or main segregation of waste, which is divided into the general waste, the infectious waste, and the highly infectious waste. So the general waste now, they will use black for it. The infectious waste now, they will use yellow. That is in the laboratory now. This one I'm teaching us is for facilities, not only laboratory. So, but laboratory now, when I'm talking about it now, most laboratory, they will use general waste, they will use black container. Infectious waste, they will use yellow container, and highly infectious waste, they will use red container. So that is what most laboratories are practicing. That is for medical laboratory. Then you can now see the disposal. How do you not dispose all this waste? You can see for disposal for cytotoxic container, you can see the chemical treatment. So if it's a drug, they will use chemical treatment for heat. They will use chemical treatment for heat to dispose them. That is after maybe it's filled up and need to be discarded. So they use chemical treatment so to disinfect before it's being disposed. So as you be buried maybe in a secure landfilling. So there you can see the red container, which is biohazard. You can see that before you discard it, you need to be autoclaved. So when the autoclave, after the autoclaving, then there will be a deep barrier. You have to dig the ground very tall before it will be buried. Then the yellow container, the same thing. Then the blue container, sometimes they recycle, although we don't encourage recycle again, this present world. So, but for those that recycle, there's need for you to disinfect very well with 1% chlorine solution. Very, very important before it should be recycled. But it's advised that you treat every infected waste as the way that one inside red plastic container is being treated. Then the same thing, your sharps. So shafts will be disinfected and being buried into a pit. Sometimes incineration is what they will do. They will carry out on shafts. So those are the common things. So note that use any colored bin other than black, red, yellow, blue, and white for disposal of yellow of general waste. That is in a general facility. Now, attention, do not allow the containers to overfeed them. Some people, they will when you enter their facility or their laboratory or whatever health facility, you will see their container, their waste containers already filled up. Some of them, the sharp is already filled up. They will still be forcing the needle inside. If care is not taken, you will get infected, you will get injured. That is a dangerous hazard. So they arrange the container near the operation area at accessible distance. I mentioned this before. So the place where you place your the area where you place your container should be the area that is accessible, so that is easily reached, not the area that will be traveling distance before you dispose anything. So ensure that the disposed item is inside the container and not hanging at the edge. So now look at the safe transportation. So the registered authorized biomedical waste transporters. See the way the vehicle used to be, the way they used to transport the waste right after it's being collected. So most some states have this kind of disposal method, like Lagos now they have Loma. So this is that. So environmental waste. So recycle your formalin. Very, very important. So very important. So that's for those that use formalin. That is how you can manage waste that maybe it's not all the waste that you not be okay, you are throwing them away, for you to also maximize your resources in the laboratory. So there's a way that you can recycle some chemicals in your laboratory. For example, formalin, ethyl alcohol, and xylene, they can be recycled instead of you to discard them. They manage all chemical waste as hazardous. So they avoid purchasing chemical in bulk. That is, any chemical you don't use, don't buy them too plenty, so that it will result into waste or get busted when it want to overreact. So reduce the number of red bag container in your laboratory. That is, don't put highly infectious waste container too many in your lab. So reduce the number that you are having, so that at least it can be concentrated to reduce the risk. So whenever possible, avoid the use of reagent containing arsenic, barium, cadmium, chromium, lead, mercury, selenium, and the silver. Avoid them if possible. So if your laboratory does not relate to using these things, so avoid them. So then documentation is also very important. There's need for you to be able to document how your laboratory waste is being managed. So very important. So environmental waste, environment and waste management is very important. So that is that. So that is the end of waste management. That is the end of waste management. So now let me go to fire safety. So that is another module, fire safety. So this is the end of waste management. That's like a recap. So module 8 now, fire safety. So once again, my name is Dr. Samuel A. Fasogbon. So I want to also teach us on fire safety. How can we manage fire? Fire is one of the incidents that usually occur in the facility, either health facility, whether your home is not health facility, wherever you are working, even at home. Fire incidents used to be common, which can arise through any source. So there's need for us to know how we can manage fire, to understand how can we manage fire in case if it come up. Then understanding that we need to have about fire safety for us to be able to avoid it, or for us to be able to quench it or to manage it when it comes up. Now, labs, especially those using solvents in any quantity, they have very high potential for flash fires. Now, explosion, rapid spread of fire, and high toxicity of product of combustion. A fire accident must be prevented as much as possible. So the reason why fire accident must be prevented as much as possible is because if you are careless about your facility, one single fire incident can come up, can destroy everything you have been doing so far. One fire incident that come up can destroy everything you have been doing so far. Can even destroy your equipment, can destroy what you have gathered over the year, can a lot of things. So there is need for you to avoid fire incidents as much as possible. So prevent it. So, and there is need for you to also understand that when it comes up, how can I handle it? You need to understand that. So preparation for response in case of fire emergency is very important. So each of these three elements must be present at the same time to have a fire. You know, fire does not just occur anyhow. So something must happen for fire to occur. So a fire will burn until one or more of the elements is removed. So when fire is burning, for you to quench the fire, one element that is contributing to that fire flame need to be quenched for the flame to come down or to die down. So that's why you need to understand three elements that involve for fire to take place. First thing, any combustible material, maybe fuel, it can be any solid material. So fire is combustible. It can be liquid, which is maybe fuel or gas. Anything combustible will be present. And inside it, there will be oxygen. So that's why inside petrol, there's oxygen there. And that's why it's easier for petrol to cause fire or gas to catch fire. So, and there will be also heat. And that is why if a vehicle is moving on the road and you see maybe there is a fire incident that happened, and maybe the vehicle has maybe some leaking area where fuel is leaking from, then the vehicle can, the fuel that is dropping from the vehicle can easily connect to that fire, and before you know, it will increase the intensity of the fire. So that is why fuel will be present, oxygen will be present, heat will be present for fire to take place. So the air we breathe is about 21% oxygen, and fire needs only 16% oxygen. I don't know if you get that. So in an environment where people are inside and they are breathing, you breathe in, you breathe out, you breathe in, you breathe out, you breathe in, you breathe in oxygen, you breathe out carbon dioxide. So there's already oxygen inside that place. So inside that place, fire can occur. So because the air we breathe in is about 21%, and for fire to occur, only 16% of oxygen is needed. Now, when we are talking about heat, the energy necessary to increase the temperature of fuel to where sufficient vapors are given off for ignition to occur. So when there is any heated material or objects, like maybe like iron, they can generate heat. So, and by the time heat is being generated, oxygen is involved, either something like fuel is involved, then fire take place. So you need to understand that. Then there are four major classes of fire. We have class A, we have class B, we have class C, and we have class D. So in the class A, we have ordinary combustible or fibrous materials such as wood, paper, clothes, rubber, and some plastic. So then class B, we have flammable or combustible liquids such as gasoline, kerosene, paint thinners, and propane. That is, they related more to chemicals. That is class B. Class A, if you don't forget, they are related to fibrous material, maybe wood, paper, your cotton, your rubber, maybe plastic, all those ones, just normal this thing. That is class A. Class B now, fire that is related to kerosene, whether fuel, gas, and maybe propane, any other chemical. The way we quench them, they are different from each other. So then class C, energize electrical equipment. You know, fire used to come up from electrical equipment. Sometimes you just hear a spark, maybe from the changeover of your house or from the changeover inside your facility. Spark like this can come up and fire will just start. And before you know, the whole roof is gone. So energize electrical equipment such as appliances, switches, panel buses, and power tools. They can generate fire. Those are the ones that we call class C. Then in the class D now, there are certain combustible metals such as magnesium, titanium, potassium, sodium, some other elements. In fact, sometimes some uranium and the rest, they can bring up fire. So those are the 4 classes: class A, class B, class C, class D. And that is why we have different type of fire extinguishers. So there's need for you to understand the class of the fire you are dealing with. Then that will now help you to know the class of the fire extinguisher you are going to use, or the manner of approach you are going to use for them. Now, fire experience. Small benchtop fire in laboratory are typical and not uncommon. So sometimes, depending on the intensity of the fire that you are dealing with, will determine how you are going to handle them. So sometimes on your bench in your facility, fire can come up from it. Can be fire that you can be able to control. So that one, they are common. So you should expect that. Then they can degenerate and become large fire if not managed properly. Small fire that you are looking at like this, fire cannot be underrated. Before you know, the whole building is down. Now, large lab fires are rare. They are very rare. So that is, they are rare because if you have put your facility and the safety in place, then large lab fire are rare. And that is why we need to say that where in your facility design, you need to consider safety. And when you are considering safety, fire safety is one of the major things that you need to consider when you are designing your laboratory. When you are about to build your laboratory or draw the design of your laboratory, you need to put safety into consideration. Now, fuel load and other level in the labs are typically very high, because you use gas, especially if it's a medical lab, where, in fact, any laboratory at all, the fuel load, there's no how you will not say you want to burn something. So then, if you know, if you say you are not burning anything, you have chemicals in that lab. You have a lot of things that are combustible in that laboratory. So it's very high. It's very high. So the lab, especially those using solvents in any quantity, they have a very high potential for flash fire. Sometimes your chemicals can just get busted before you know, fire has come up. So explosion, rapid spread of fire, and high toxicity of product of combustion, either heat, smoke, or flame, they can come up. So those are the fire experience that can come up. Then how can we not prevent them? Plan work. The majority of the lab fire have resulted from mental or procedural errors or carelessness. And that's why we are saying that you should put your laboratory in place very well. Let the safety measures be put in place very well. In fact, part of the thing you need to put in place is your safety manual, which should be understood, read and understood by every lab staff. Then should be put into work. Now, minimize materials. Have present in the immediate work area and use only the minimum quantity necessary to work in progress. Don't just jam pack your beds with different materials where you don't need them. So know the type of test you are running. Know what you are doing. Let only the reagents or the material or the chemicals that you are using for them be on the bench at a particular time. Don't just jam pack your bench or clock your bench with different things that are not necessary. So people will just pack cotton wool, tissue paper. It is not advisable. So minimize the quantity of things that you put on your work area. Then Not only that, or not only does this minimize fire risk, it also reduce cost and waste. It reduces cost and waste. Then observe proper housekeeping. Keep work areas uncluttered, I mentioned it, and clean frequently. So when we, especially from the council, by the time we go for inspection to different laboratories, you see what they are practicing. You see many laboratories untidy. They will not even clean. You see the bench not clean. You see a lot of things. You will see syringe cover lying everywhere. Sometimes you even see syringe, cotton wool soiled with blood on the floor, and different kind of nonsense practice. So keep work areas uncluttered and clean frequently. Put unneeded materials back in storage promptly. Keep access, doors, and access to emergency equipment unobstructed at all times. There are sometimes that you enter some facility, the way they even put the fire extinguisher, you know that maybe they just put it there for decoration, because the way they will tight it, the way they will put the cage, put key, it is well with you. So very, very important. Now, observe proper safety practices. Very important. Safety practice must be practiced. And if you must observe safety practices, you need your laboratory need to have safety manual, which should be read and understood by all the staff and should be observed and put in place, and necessary documentation must be done. Then store solvent properly. The solvent must be stored properly. Observe restriction on equipment. Keeping solvent only in an explosion-proof refrigerator. Then keep barriers in place. That is shield, wood doors, lab doors. This one is very, very important. But in case if emergency fire comes up, and maybe your door is very difficult to open, or you don't have emergency door, and the place where the fire is coming from, you can't access it to get your exits, then it's very bad. It's very dangerous. So that is why we used to advise emergency exits for laboratories. So keep barriers in place. So wear proper clothing and personal protective equipment. That's your PPE. Wear them always. Your lab coats, your goggle, because imagine that you are working with you are trying to maybe inoculate or culture your plate. Now, if you don't wear your face shield or your eye goggle, maybe the fire just come up, wah, and your eyes is there. That one is a problem. So you wear your personal protective equipment. Avoid working alone. That is it. So that if anything comes up, another person can be able to raise alarm. But eventually you cannot raise the alarm yourself. So plan. Have a written emergency plan for your space and or operation. Then training. Exercise the emergency plan and learn to use emergency equipment provided. Very, very important. So that is why we are carrying out a training like this for you people, so that you can learn, you can train, you can understand. Then in the laboratory, there is need for you to give your staff training, even you train how to handle safety. Fire safety comes up, how will I handle it? You need to understand it. So many of us here now, you can't operate fire extinguisher. If they say operate fire extinguisher, you can't operate it. That is very, very bad. So everybody need to be trained. So avoid use of phone when working in the lab, especially with flammable reagents. We have been warning this since. Avoid use of phone, because phone has a way of bringing up a flame or bringing up fire when they are close to flammable reagents, because of the connection that they have with each other. So avoid use of phone in the laboratory when working. Very, very important. Now, fire emergency. Know what to do. You tend to do under stress what you have practiced or pre-planned. Know where things are. The nearest fire extinguisher, fire alarm box, then exist, telephone, emergency shower, eye wash, and first aid kits. Very, very important. When you employ a new staff, these are part of the training that the new staff should be put through. So the person needs to understand where all these things are kept in case of emergency. When laboratory today, they will just employ staff, they don't explain this to them, they don't give them training, which is very bad. So be aware that emergency are really clean and will often involve more than one type of problem. So for example, an explosion may generate medical, fire, and contamination emergency simultaneously. So, and that is one of the reasons why you must know where things are. So now when you notice fire, these are the things that you will do. Maybe you are working and you notice a fire in your facility, or maybe anywhere you are. What you do is to pull the nearest fire alarm. So fire alarm is very important in the laboratory. So you pull the nearest fire alarm, that is, we call it the pull station, while exiting the floor. So if there is no pull station, then this one is not available in Nigeria. If they say die 911 or emergency number or alternative emergency number, no. So do not assume that anyone else has already called the fire department. So don't assume that they have already called the fire department or they have already pressed the alarm. So immediately you notice it, do the right thing. So stay calm and be prepared to answer the operator's questions regarding the emergency. And that is why most of the laboratory you will see the alarm system, they have connected it to strategic areas that they are easily accessible. They are accessible, so that immediately you notice anything fire, then you press the fire alarm system. So we also have some things that they used to install in different facilities now that we call smoke detector. So that smoke detector now, by the time the smoke is being perceived, the smoke detector is one that will even raise alarm. So then what you do again is to evacuate. By the time you see that this fire is coming up, you evacuate that place immediately. So then when you hear the fire alarm, continuation, what do? Close doors behind you. Close the door behind you as you are trying to evacuate. Close the door behind you as you are evacuating. Close the door behind you. However, do not lock the door, because if you lock the door, you might hinder the fire department or the rescue officer to be able to access the place to quench the fire. So don't lock the door. So just close it, don't lock it. So the stairway will be your primary escape route. So you'll be looking for the stairway so that you can be able to escape. So never use elevators under any circumstances. For those of you in a sophisticated facility where they have elevators, when there's fire incident, don't use elevators, because you don't know the extent where the fire has gotten to. You don't know whether the fire has gotten to some of the panel of the elevator. And by the time you try to use the elevator, maybe before you get to the down stair where you are going to, maybe the elevator will go spoil and you will get hooked there. Very difficult to save you there. So don't ever use elevator under any circumstances. Use the staircase. Once in the stairway, proceed down to the first floor, that is the downstairs, and out of the building. Then never go up. I forgot my makeup, I forgot my phone, I forgot this. That is not advisable. So after a fire emergency, once you are out of the building, stay out. Do not go back inside for any reason. Then report to your warden for roll call at your designated assembly point. Tell the fire department, fire your warden if you know of anyone trapped inside the building. Then only re-enter if and when the fire department tell you it is safe to do so. So it's very important. You need to know that. So fire procedure. Notify other occupants in the immediate space. You need to notify people. Don't just be selfish. So other occupants of facility, you can notify them, as I said before. Use fire alarm. Then emergency responder. Then evacuate the area immediately. The area of the problem, evacuate the place immediately. Then the space which the problem has occurred, evacuate the place. So they evacuate the building within which the space is located. Then when you are talking about isolate now, lower wood search, close lab doors, close corridor doors. If safe to do so, attempt to also extinguish. That is, if you see that it's safe to do so, try to also use your fire extinguisher. Very important. So now, never fight fire if the fire is spreading beyond the immediate area in which it started, or if it's already a large fire. Don't try to fight it so that the fire will not affect you too, so that you won't get yourself into trouble. Now, the fire could block your escape route. Because if you are trying to fight it, before you know, you cannot be able to escape again. The fire has already blocked it. You cannot underrate fire. So you are unsure of the proper operation of the extinguisher. Don't ever fight the fire. If you don't know how to use the fire extinguisher very well, don't try to stop the fire. If you don't know how to use the fire extinguisher very well, don't try to stop the fire. Once again, if you don't know how to use the fire extinguisher very well, don't try to stop the fire. You doubt that the extinguisher you are holding is designed for the type of fire at hand or is large enough to fight the fire. Don't fight it. If you see that maybe you don't know the type of fire extinguisher that you are carrying, or you don't know the source of the fire that you are about to try or attempt to extinguish, don't even try it. So run for your life. Now, fire extinguisher alternatives. And extinguisher is a first aid tool. So don't expect it to control a big fire, as I said. So for small isolated fire only. So fire extinguisher is useful for small and isolated fire only. If the fire is too big, don't try to fight it. You know, I'm repeating it. So must be inspected and have a current chart by the fire service to avoid expired fire extinguisher. So there is need for your fire extinguisher chart to be regularly inspected so that they can be able to ensure that is always in service, that it has not expired. So then sound bucket, fire blanket should be in place. Periodic fire training is recommended for fire service authority and also documentation. Now, we have multi-class racing. Many extinguishers available today can be used on different types of fires and will be labeled with more than one designator. So you can have the fire extinguisher like they say A to B, that is, can quench only fire for any type of fire, whether A or B, B or C, A, B, C. So this label shows that this extinguisher can be used on ordinary combustible A or flammable liquid B. The red slash through the last symbol tells you that the extinguisher cannot be used on electrical fires. So we advise that most fire extinguisher will function for less than 40 seconds. So you need to know that. So that is that. So you can see the logos of those fire extinguishers. You see A, where you see A on it, you will see that it's for type A. The B, you know that it's for type B. C is, you know that it's for type C. And you can see ordinary combustible, that is for A. You can see it. Flammable liquid, electrical labeling. Electrical labeling. So that is that of the electrical equipment rather. So that is that done. Now, quickly, how to use a portable fire extinguisher. So when we're talking about the portable fire extinguisher, how to use it. So there is an acronym that we call PASS. There's an acronym that we call PASS. So this acronym PASS, it means, that is PASS. It means pull the pin, aim extinguisher, squeeze trigger, and sweep the extinguisher. So what you have is that there's a pin at the edge of that extinguisher. So you pull the pin. So when you pull the pin, then the A now, you will aim the extinguisher nozzle at the base of the flame, not at the top. The base, that is the bottom. So you aim the extinguisher at the bottom of the fire, at the base of the fire. So when you aim it, don't press that trigger yet. Don't extinguish yet. Aim it. When you have aimed it, then that's when you now squeeze the trigger while holding the extinguisher upright. The extinguisher will be standing upright. You now hold or squeeze that trigger after you have aimed the bottom. So then you will now be sweeping it. So sweep the extinguisher from side to side, like this, right and left, right and left, right and left, that is side to side, covering the area of the fire with the extinguishing agent. So I come again on that one. There's a pin at the top of the fire extinguisher container. You pull the pin, immediately you notice fire, you remove it from where the fire extinguisher is being hung. After you removed it, you pull the pin. When you pull the pin, then you aim. There is something like a nozzle. That nozzle, you will hold it. When you hold it, you now aim it at the bottom of the fire, not at the top, not at the middle, at the bottom. So when you aim it at the bottom of the fire, then you now start squeezing there is something that be like a clip at the top of the fire extinguisher. You now start squeezing it. Then as you are squeezing it, you hold the container very well. That extinguisher container, you hold it very well and upright. Then you start squeezing it. When you are squeezing it, then that nozzle with in your hand, you will now start extinguishing, now moving it from side to side to cover the area the fire as a spread to with the extinguishing reagent. So now 10 tips on how you can use your fire extinguisher. So now most fires start small. So except for explosion, fire can usually be brought under control if they are attacked correctly with the right type and size of extinguisher within the first 2 minutes. So this is a see on how to use fire extinguisher. So now that is first step. The second step, a fire extinguisher should be listed and labeled by independent testing laboratory. So the higher the rating number on an A or B extinguisher, the more fire it can put out. So be careful. High-rated units are often heavier model. So make sure you can hold and operate the model you are holding. So see this person, see that number 1, see that how the person is holding, how that guy is holding that fire extinguisher. Are you getting it now? So see the 2, see how he's holding it. So make sure you check the labeling on the body very well. Then 3, before attempting to fight a small fire, be sure everyone is out of the area. Ensure someone has called the fire department. If the fire starts to spread or threaten your escape path, get out immediately. What did I say? If the fire starts to spread or threaten your escape path, get out immediately. Don't form champion. Get out immediately. Leave the firefight for the fire expert. So then the first tips, the operator must know how to use the extinguisher quickly without taking time to read directions during an emergency. So remember that the extinguisher needs care and must be recharged after every use. So it's not that maybe after you have quenched the fire now, you now go back and put it there. Then you're not expecting that one demon or one spirit will now come and load it for you again. So you need to take caution of that. You need to, that's one of the reasons why you need documentation, so that you can, after use of the fire extinguisher, proper care need to be taken so that it can be recharged. Now, the 5. So if you fight a fire, then you must understand this pass. Pull, aim, squeeze, sweep. That is the pass. Pull, aim, squeeze, sweep, as I explained earlier. So pull now, the pin. That is the pin. You see the pin. You can see the illustration on my slide. I hope everybody can see. Can you see? Hello? Are you there? Hello?
We can see. We can see it.
Okay, good. Good. So you can see the pin. That pin now, you will remove it. That is the pull. So some extinguisher require releasing a lock latch. That is, there's something that used to be like a red band. So sometimes before you can be able to pull that pin, you will remove that band. That's what they call the lock latch. So you press a puncture lever or other motion. So then you need to now aim. That is the tip 6 now. You aim. So low, pointing the extinguisher nozzle or it's on or off at the base of the fire. You can see this illustration that I'm showing us now. On the base, not at the top. Because if you are putting it at the top, you'll be increasing, the fire will be increasing. So you aim the base. So now squeeze the handle. This is the handle I'm talking about. If you see, that's number 7. That's the handle. You squeeze it, the handle. Then as you squeeze it, then you will now start releasing it. This releases the extinguisher agent. As you squeeze it, as you will be releasing it, as you squeeze it. If you want to use it, you squeeze it. So as you squeeze it, then the extinguishing agent will be released from the fire extinguisher. So then you now sweep it. So sweep from side to side at the base of the fire until it appears to be out. So you take the nozzle, you sweep it. So watch the fire area in case fire break out again. So, and repeat use of extinguisher if necessary. So, read and follow the direction on your extinguisher. Read and follow the directions on your extinguisher. If you have the slightest doubt about whether or not to fight a fire, don't. By the time you are trying to fight a fire with your fire extinguisher and you discover that the fire is too large, or you have a doubt, I can't control it. Hey, with this thing, so far you are having doubt, my friend, run, oh, run. Oh. So very, very important. So because your life is more important than whatever you think you want to save. So get out and close the door behind you. So if you have any doubt, after when you have read the instruction and you have any doubt that maybe this thing I cannot handle it, then get out and close the door behind you. Close, not lock. Don't use key. Because by the time fire get there and fire burn the this thing, it's very difficult to open. So just close. I'll back. Let me use back the door. So that is number 9. And number 10 is remember. Number 10 tips is remember. Your safety comes first. When in doubt, leave the fire. Are you getting it now? When in doubt, leave the firefighting to the professionals. There are people that are more trained than you in firefighting. So, but you just need to get this knowledge so that you can be able to understand and be able to handle it. So your safety comes first. When in doubt, that is when you think that, this thing I cannot handle it or it's too light. Run, no. That is, leave the firefighting to the professional. Very, very important. So there are signs that are noticed. Safety notice and sign must be posted in all labs and depots. All signs must be clearly visible and adhered to. Then obscure, faded, or damaged sign must be replaced as soon as possible. Exit signs, very, very important. They are very important in the lab. In fact, from the lab, from the MLSCM, from the council, if you go for any inspection, we used to hammer on exit sign. In fact, all these things I'm mentioning. Now, in small depot with only one obvious exit, the sign are not necessary. So flammable storage sign. No smoking and no open flame. That is, you have to put no smoking, no open flame in your laboratory, all the corners, especially at the reception, because there are some or your facility. If you know that your facility deal with the things that can cause fire, so you have to be very careful in allowing smokers or people that can bring anything combustible into your lab. So flammable, science may be needed, no open flame. Then science may be needed if flammable store is not located in the laboratory. So these signs are not needed if the flammable store is located within the laboratory. So safety sign for fire blankets, safety sign for eye wash, bottle and shower sign, sign for first aid, sign for first fire extinguisher, maybe 2 sign, bottle and arrow, or the rest. So on this note, I want to bring this lecture to a close because there is no time. We can't finish everything that's related to waste management and fire safety just in 1, 2, 3 hours. So, and our time is far spent already. It's supposed to be 45 minutes to 1 hour lecture, but we have spent more than that already. So I hope the explanation that I've given make us to understand very well. But in case if you don't understand, you can raise your question. So waste management, fire safety, they are very important aspects of the earth facility that should not be joked with. So I want to thank you all for listening. I want to hope that you have gained a lot from this lecture, and I want to congratulate you for that, at least for even considering to take up this trip. So God bless you. So my name again is Dr. Samuel Fasogbon. Thank you. So questions now? If you have questions, You can raise your question, please. Anyone with question? Anyone with question? So then if you know you don't have any question, do we all understand?
Hello.
Yeah.
Thank you for your wonderful lectures.
You're welcome.
My question is, talking about